Hi guys, this is Shahir here, your instructor at Solvit. So this is the first video for IBA Math Test Prep, and in today's video we are going to cover arithmetic problems. Even though this topic is not that much tested, but we just need to go over this topic so that we have a good grip of basic elementary math that is required for the preparation of the test. So without any delay, let's just start. The first thing that we're going to cover is the type of numbers. So let's just look into what integers are. So integers are all the whole numbers are said to be numbers are said to be integers, including 0. So what does this mean? That all the positive and negative numbers, including 0, are said to be integers. So for example, it could be negative 10,000, positive 999. Any whole number is said to be an integer, including a 0. So the next number that we are going to look towards are even numbers. So what are even numbers? Even numbers are said to be all the numbers that are divisible by 2. Let's just write down all the numbers that are that are divisible by that are divisible by 2 are said to be even numbers. For example, the best example would be 4, 6, 8, 10, 64, 128, 196. Anything that is divisible by 2 is said to be an even number. अब odd numbers क्या हैं? Odd numbers are all the numbers that leaves a remainder of 1 when they are divided by 2. All the numbers that leaves a remainder of 1 when they are divided by 2. 2. So that is the best example of it could be 5, 7, 9, 11, 13, 25, 27, 99, 127, anything. So basically, all non-even numbers are said to be odd numbers. The next thing that we need to look at are factors. So what are factors? Let's just look at that. So factors are basically all the numbers that divides another number and leaves a remainder of 0. All the numbers that divides another number and leaves a remainder of 0 are said to be the factors. So for example, the best case in this would be that the factors of 6 are, so let's just look at factors of 6 are, because 6 divided by 1 would give us a remainder of 0, so that means 1, 2 also, 3 also, and 6 itself also. So that means the factors of 6 are these numbers. You can do that for any bigger number as well. Let's just do it for 60. Factors of 60. So the best way to find out factors of any number is the product method. That is, that write down all the combinations of numbers that multiply and becomes 60. So let's just start by writing the first number, that is the product of 60. Let's start from 1. So 1 multiply by 60, 2 multiply by 30, 3 multiply by 20, and then 4 multiply by 15, and then 5 multiply by 12, and then 6 multiply by 10. Okay, now we need to stop at by like the point where we need to stop. The hint for stopping is that the combination would like the last combination of the number would be the one जिसके बाद the combination would start repeating itself. Like in this case, the next combination would be 10 multiplied by 6. That means इस point पे we need to stop, and the all the combinations we have made already, the numbers in those are already the multiples of the factors of 60. That is 1, 2, 3, 4, 5, 6, 10, 12, 15. इस मेथड के थ्रू आप लोग कोई भी नंबर मिस नहीं करोगे कभी भी. अब वो ट्रायल एंड एरर से या गेस करने से देयर इज अ चांस ऑफ मिसिंग आउट ऑन अ नंबर. So now let's look at multiples. So what are multiples? Let's just look at that. Multiples multiples are all numbers that are there in a times table. So for example, this is just a very easy to understand definition of multiples. So the best example of multiples is, for example, multiples of 7. Multiples of 7. अब 7 के टेबल में whatever numbers are there are said to be the multiples of 7. Simple सी बात है. 7, 14, 21, 28, 35, 42, 49. So these are the first 7 multiples of 7. All right. Now let's look at irrational numbers, because since it's easy to figure out that what are rational numbers, but the only thing we get stuck at is irrational numbers, and this thing can be tested in your IBA math test. So let's just look at that. What are irrational numbers? Irrational numbers are all the numbers that are in between the two perfect square roots. Okay, so what do I mean to say is, I'll explain you that irrational numbers between between 4 and 9. So now the square root of 4 is 2 and square root of 9 is 3. So basically the under root of all the numbers, that means square root of all the numbers between 4 and 9 won't be a perfect square. So under root those numbers, under root all the numbers between 4 and 9, that is 5, under root 6, under root 7, under root 8, are said to be irrational numbers. This is because these numbers cannot be written into a fraction form or the ratios of two integers. All right, guys. So now let's just look at the basic rule of arithmetic, that is BODMAS. अब BODMAS क्या state करता है? So first of all, let's just see what kind of question can sit in the exam. So the question that will be sitting in the exam will require you to follow a certain order of operations for arithmetic. So for that, you need to do BODMAS. BODMAS states that brackets of division, multiplication, addition, and subtraction. So this basically means brackets. First of all, you need to do bracket, then you need to do division, then we need to do multiplication, then either we can add or subtract. So this is first, this is second, this is, of course, any of them could be third or fourth. So this is the order that we need to follow while solving the question for the order of operations. So now let's just look at the question number 16 in the worksheet that is uploaded on the Google Drive for arithmetic problems. Let's just look at question number 16. All right, so now let's just look at question number 16. What does it state? So the question number 16 states that 32, that x, if x is equals to 32 minus 16 divided by 2 multiplied by 4. So the first operation that we need to do is minus 16 divided by 4. Why? Because the question needs to follow the order of operations, that is BODMAS. So when 32 is divided by 16, that would give us the x equals to 32 is minus 16 divided by 2 multiplied by 4. That is the question. So when minus 16 is divided by 2, it would give us 8. And then we'll have to multiply. So 32 minus 32 would give us 0. So x would be equal to 0. That is the answer for this question, following the order of operations, that is BODMAS. So guys, now let's just look at how do we conduct different operations when the decimals are being involved. By operations, I mean to say that how do we add, subtract, multiply, or divide when the decimals are involved. And why is it important? Because calculator होगा नहीं exam में, and we'll have to do all the working on our own. And there can be decimals involved in the questions, in the working of the questions. So it's just better that we learn it now and then we can move on. So let's just look at addition in, involving decimals. So let's just look at that. So when additions are involved in decimal. So there is a rule that, okay, so let's just, the question says that we need to add 2.0685 plus 5.9284. So let's just add this. So the rule is that you need to align the decimals and add. तो यार अलाइन द डेसिमल्स का क्या मतलब है 2.0685. अब decimal should come under the decimal. Now we can write 5.9284. So 5 and 4 will add and become 9. 8 and 8 will add and become 16. 1 is carried forward. 6 and 2 would add and become 8, and so, but 9, because since the 1 is on top of 6, then this 9, and then this 7, so 7.969. All right, now let's just move on with subtraction in decimal. So subtraction in decimal is basically, let's just look at an example, 7.548 minus 3.679. So again, the rule is to align the decimals. Align the decimals. All right. So let's just look at how do we subtract these. So first of all, पहले align कर लो. तो 7.48 minus 3.679. Align हो गया. Now let's just start subtracting. So 8 cannot be subtracted from 9, so we'll have to borrow 6, 14. All of this might seem very, baby math, but then we need to know all of this to sit for IBA test and ace that test. 13 minus 7 becomes 6, 14 minus 6 becomes 8, and decimal will come in place of decimal. 6 minus 3 is 3, so 3.869 is the answer for this. All right, now let's just look at the multiplication of decimals. Let's just look at multiplication of decimals and what's the rule for that. तो पहले क्वेश्चन देखते हैं एक मल्टीप्लिकेशन ऑफ डेसिमल्स का क्वेश्चन देखते हैं. So multiplication of decimals का question is that we need to multiply 2.48 by 7.6. So in order to do that, let's just look at the rule. The rule says count the decimal places in both the numbers. Okay, so let me just explain you what do I mean to say when I write this rule. Count the number of decimals and place in product in the answer. Okay, so now what do I mean to say is, I mean to say the question क्या है? The question is 2.48 multiplied by 7.6. So 6 eights are 48, 6 fours are 24, 28, 6 twos are 2, and 12, and it will become 14. Multiply 7 eights are 56, and 7 fours are 28, it will become 33, 7 twos are 14, and it will become 17. So 8, and it will become 8 plus 6 is 14, 8, 8, and 1. So now, so let's just place the decimals by reading the rule. So what does the rule say? The rule says, let's just read the rule. Count the number of decimals and place in the answer. So let's just count the number of decimals where? Count the number of decimals in the question. Up in the question, in the like in the numbers in the question. तो अब यहाँ पे कितने decimal places हैं? यहाँ पे 2 हैं, यहाँ पे 1 है. So that means in total we need to place 3 decimal places in the answers, counting from right to left. So that means 1, 2, and 3. So the decimal would come at this point. So in the final answer, it would be 2.48 multiplied by 7.6 would be equal to 18.848. Okay. So then let's move on to division of decimals. So whenever there is division of decimals, we don't need to worry. Let's just convert all of them into fractions and then solve. That's the easiest method to solve the decimal divisions. So let's say division of decimals. So division of decimals में, let's suppose I have a question that says 0.55 multiplied by 0.5. Okay, let's make it a little more difficult by adding another decimal place to this. So let's suppose this will become 0.05. So now we need to divide 0.55 by 0.05. So how will I do that? The rule for this is convert all the decimals to the fractions. Okay, so now 0.05 divided by 0.55 divided by 0.55 can be written as this, right? first of all, it was written vertically, but I wrote it horizontally. So now if I need to convert 0.55 into a fraction, it would become 55 over 100, because if I move this decimal two places forward, I'll have to add two zeros in the denominator, and then this would become divide, and this would become 5 upon 100. So now can you just write it as 55 over 100 multiply by 100 upon 5, since I am changing this sign of division into multiplication, so I will reciprocate both of them. So now let's just cancel this and this out. 5 ones are 5, 5 11s are 55, so the answer of this would be 11. At the start, the question seemed a little difficult because it was written in the decimal, but we converted it into fraction and we solved it. All right. So now let's just look at, wait. Okay. So let's just look at another example. And that example states that 0.35 divided by 0. Question लगता है 0.35 divided by 0.005. So let's just divide that. So it will become, so first, what's the first step? Let's convert everything into fraction, every decimal number into fraction. 35 over 100. Okay, no, skip this step. So 35 over 100 divided by 5 over 1000, and now I can reciprocate it like that, right? So then it will become 100 ones are 100, 100 times 1000, 5 ones are 7, and it would become 70. Are we good till here? Okay, so now let's just move on to the fractions and the operations in fractions. So let's just look at addition in fractions. The addition in fractions. So let's just look at addition and subtraction in fractions, because it follows the same rule. Addition and subtraction in fractions, since it follows the same rule, so let's just look at it together. So let me write down a question. The question states that 2 over 3 plus 5 over 7. It's just so basic. So what is the rule? So the rule states that for both of these operations, make the denominator equal and solve. तो यार देखो, how do we make the denominator equal? The 2 over 3 plus 5 over 7. So to make the denominator equal, we multiply this by 7, this multiply it by each other, or you can even multiply it by the lowest common multiple of both, or more than 2 of both the denominators that are there, or all the denominators that are there. So 5 multiplied by 3, the 2 multiplied by 7 would become 14, 14 plus 15 over 21. So it will become 29 over 21. And if we say that, let's just do another question for subtraction. So for subtraction, it is given to us that 7 over 9 minus 4 over 8. So how do we do that? So again, let's just figure out the lowest common multiple of both. So the lowest common multiple of 8 and 9 would be 72. So now let's just multiply it by 8 and this also by 9. By 9, 7 8s are 56. 56 by 36 over 72. 56 by 36 would become 26 by, oh no, 20 over 72. That is 10 over 36, or you can even say that 5 over 18. So that was it for the subtraction of fractions. So now let's just look at the multiplication of fractions. That is the multiplication of fractions, like let's just look at that. So for multiplication of fractions, we need to figure out a few things before, that are the fractions. If a fraction is given to us, that is a over b multiplied by c over d. This is a fraction. This is an example. I'm just trying to explain something to you, that the decimals, the fractions are allowed to cancel out a number into another fraction or into the same fraction just vertically or diagonally, but it cannot cancel out a number horizontally. What I mean to say is that we can cancel out like or this, this, or this, but we cannot cancel out horizontally. All right. So now let's just look at an example. An example states that 3 over 7 multiply by 9 over 27. So now it's not that I can cancel out this 3 with 9 or this 27 with 7. Although I can cancel it out vertically or diagonally. So let's just cancel it out. So 3 ones are 3, 3 nines are 27, 9 ones are 9, and 9. So now it would become, the answer would become 1 over 7. All right. So let's just move on to the division of fraction. So the division of fraction is again a very basic concept, because whenever two fractions are, okay, so let's just look at that. Division of fraction. Division of fraction is again a very basic concept. Why is that so? Because we don't need to divide fractions. We can convert them into a multiplication by just reciprocating the a decimal that is on the right of the, sorry, a fraction that is on the right of the division sign. So for example, if I have given a over b is to be divided by c over d, that means we don't exactly need to divide it. What we can do is we can convert this division sign into multiplication, but to do that we'll have to reciprocate this one. So that means it would become a over b multiplied by c over d, and then we can simplify it by cancelling it out diagonally, vertically, but not horizontally. So guys, now let's just look at another concept that is there in arithmetic, that is called prime factorization. So I'll just revise that with you guys. So now, what is prime factorization? Abhyar, prime factorization is basically writing down a number into the product of its prime factors. So writing down a number into the product of its prime factors. What are prime factors? Prime fact There are factors that divides a number in a way that it leaves a remainder of zero. So what are prime factors? Prime factors are all the factors that are also prime numbers. Prime numbers are the numbers that are there in one times table and themselves times table. So let me just write it down over here. What are prime numbers? Numbers that are there in one times table and their own times table. So now prime factorization is when we write down a number into the product of its prime factors. That means the factors that are prime numbers. So for example, if I tell you to write down the prime factorization of 172, so what it would be? So the prime factorization of 172 would be done by using the ladder method. which is this. 2. Okay, so what's the first prime number that divides 572? So 2 divided by 572 would become 256. 2 divided by 256 would become 128. 2 divided by 128 would become 64. 2 divided by 64 would become 32. And then 16, and then 8, and then 3, and then, oh no, 4, and then 2, 2, 2, 1. So can I say that it becomes 2 into 2 into 2 into 2 into 2? How many times 2 basically? 1, 2, 5, and 9. 5 and 9. So that means this is how it's done. So this is the prime factorization of 572. I can also write it into into another form that is called index notation form. That is this. This is called an index notation form. That is just squeezing the number of times 2 is there by writing it all the numbers as a power. So let's just look at what are the applications of prime factorization. Prime factorization basically helps us to figure out the HCF and LCM. So what is HCF? HCF is basically the highest common factor. So, what is highest common factors? All of us know that two numbers can have common factors. So, we just need to figure out what is the highest common factor. Highest common factor is figured out by using prime factorization. So, how do we do that? Let's just look at that. So, let's suppose if I tell you to do Let's suppose if I tell you to solve the prime factorization or the HCF of 56 and 48. Okay, so now let's just look at how do we do by using prime factorization. So we will start prime factorization of both the numbers till they till the point where they are divided by the same number. So if I start prime factorization of 56 and 48, what am I going to do? I'm going to start dividing it by the smallest prime number, that is 2. 2 divides both the 56 and 48. So when 56 divided by 2, it will become 28, and 48 divided by 2 would give us 24. Then we would move on and see what is the other number that divides 28 and 24. That is again 2. 2 14s are and 2 12s are. Then 14 divided by 2 would give us 7, and then it would give us 6. So now 7 and 6 are the two numbers that cannot be further divided with the same number. That means I'll have to introduce another 7, and we'd have to divide it for the 6 by 2 and 3 to continue this prime factorization till 1. But the trick for HCF is, the rule for HCF is, rule is keep dividing by a prime number until a same number is used to divide. So that means it's going to become, the answer is just this. So then the answer for HCF would be 2 into 2 into 2. So that means the answer for HCF is 8. All right. So now let's just look at another application for prime factorization, that is LCM. So LCM is what? LCM is basically lowest common multiple. All of us know that there can be common multiples. For example, the common multiple of 6 and 2 is 6, because 2 threes are 6 and 6 ones are 6. 2 and 4 could be 4. 2 and 9 could be 18. But we need to figure out that what is the lowest common multiple. So lowest common multiple is again figured out by using prime factorization. It's again figured out by using prime factorization. Let's just see an example where we need to figure out the LCM of 12 and 14. So let's just look at that. 12, 14. So two sixes are, two sevens are, but since it's the LCM, we need to make the prime factorization of each number till 1. So that means we'll be further dividing it. Two threes are, two three ones are, and then seven ones are. तो इसका क्या हो जाएगा? It will become the prime factor, the LCM would become 2 into 2 into 3 into 7. So the LCM of this, of LCM of 12 and 14 will become what? 2 to the 4, 40 to 12, 12 sevens are 84, so 84. So the rule for this is keep dividing, keep dividing by a prime number till each number becomes 1. To practice this concept, all of you can solve question number 12 in the worksheet on the drive for arithmetic problems. Now, I'll just be solving a few questions with you guys that are there in the worksheet, but I haven't discussed their concepts over here. So guys, this is question 10 from the worksheet, and this question is basically very easy. There's like something that I taught, that is the division of fractions and the addition of fractions, that is just there. The concept is the same. It's just one of those applications of the concept that I just taught you. So let's just do it. It's very repetitively tested in the exam. So let's just look at that. So 3 over 4, okay, so what does the question say? Let's just read that first. So the question states that find the fraction exactly halfway between 3 over 4 and 4 over 7. So we just don't need to convert it into decimals and then find out the middle number. What we can do, we just know that the middle number of the two numbers is, find it out by adding the middle number and then dividing it by 2. So for example, if I need to figure out the middle number between 2 and 4, what am I going to do? I'm going to add 2 and 4. I'm going to add 2 and 4 and then divide it by 2 and then see what is the middle number. So it is going to be 2 plus 4 is going to be what? 6. 6 divided by 2 will give me 3. So that means 3 is the middle number. Similarly, it's the same type of question, but since there are just fractions that are there in the question. So let's just do it the similar way. 3 over 4 plus 4 over 7 divided by 2. So now to add them, what am I going to do? I'm going to first add the fractions on the top. So to add the fractions on the top, what am I going to do? I'm going to make their denominator same by using the LCM. So the 7 or 4 ka LCM is 28, 3 sevens are 21, 4 fours are 16 divided by 28. This whole thing is now divided by 2. Either you can write it this way, or what you can do, you can write it this way as well. So now 21 and 16 would become 37. 37 divided by 28 would be this, and then this division could be converted into a multiplication by just reciprocating this fraction. So then this would become 1 over 2. So all of you that are confused but that how did I put this 1? So whenever an integer is written, for example 52 is written, so that means it already has a 1 under it. That is never written, or like it's never shown, it's always there. So that means this would become, or you can just say that if a number is a, the reciprocal of a would be 1 over a. So if the number is 2, the reciprocal of 2 would be 1 over 2. So now it would become, now you cannot like simplify it any further. So you just become 28 into 2 would be 56. So the answer is 36 over 56. That is 37 over 56. That is C. So guys, let's just look at this question number 11, that says we need to find out the difference between 1 whole 3 over 5 and its reciprocal. So that means 1 whole 3 over 5 is first of all written like this. Let's just convert it from mixed number to an improper fraction. So it will become 8 over 5. Then what we need to do is we need to find out the difference between 8 over 5 and its reciprocal. So that means its reciprocal would be something like this, 5 over 8. Then we need to figure out the difference. That we can do by just making the denominator same. So it will become this, and this will become this, multiplied by 5, and this will be 8 8 is 64, 64 minus 25 over 40. So 64 minus 25 would be 39, 39 over, oh sorry, 39 over 40. So that's it. This is it for the lecture of arithmetic problems, and I'd be seeing you guys in the next lecture. Till then, just solve all the problems that are uploaded in the worksheet of arithmetic problems. Thank you.